Welcome back to this channel. In this class video, I'll be taking you guys the full calculation on momentum. Okay, I'm taking guys full calculation on momentum. Now, in our previous class, I taught you guys all you need to know about momentum, such as impulse, the conservation of momentum, as well as the application of the conservation of momentum, such as the recoil of a gun, whereby I gave you guys the formula, then collision, as well as rocket propulsion. Okay, so in today's class I'll be doing the calculation aspect of momentum. So please, if you have not watched that class video, I will advise to watch it, because in that video I really explain all you need to know about momentum. I gave you guys some important formulas, and also I will advise you to go to watch that video before coming to this part. Okay, now let's start with this class. Okay, so if you look at the board here, you usually see three questions. Okay, now let's start with the very first question. It said high speed photography reveals that when a bat strike a baseball, a typical collision time is about 0.25 seconds. If a speed of 35 meter per second is imparted to a ball of mass 0.325 kg, what average force is exerted by the bat? Now let me read the question again. High speed photography reveals that when a bat strike a baseball, okay, let's use the bat, okay, this bat let's use the bat, then let's use the baseball. The bat strike the baseball. A typical collision time is about 0.25 seconds. So the collision time between the bat and the baseball, the collision time is 0.25 seconds. Okay, let's say if a speed of 35 meters per second is imparted to a ball of mass 0.325 kg, what average force is exerted by the bat? Okay, so they're asking us to calculate for the average force. Okay, what formula are we going to use? This question is very, very easy. Okay, remember Newton gave three laws of motion: the first law, the second law, and the third law. Now the second law is also known as the law of momentum, right? Now what does this second law state? So in the second law of motion states that force is equal to what? Ma, right? Yes. This second law is also known as law of momentum. Okay, so this is Newton's second law. Force equals to mass times acceleration. And don't forget that acceleration is still equals to what? V minus c over t, right? Yes. So we are looking for this force. Okay, so let's just continue. The mass of the what is the mass of? Okay, if a speed of 35 meters per second is imparted to a ball of mass, so this is the mass. Okay, so which is 0.325. Okay, bracket open. Okay, bracket open. Then the final velocity of the ball is let me see. If a speed of 35 meters per second, so the final velocity is 35 meters per second. Okay, then what about the initial velocity? Initially to be 0, right? Yes, because at that time initially when the ball was not has not been struck yet, so initially the velocity of the ball is 0. Then the time, okay, let me see. When a bat strikes a baseball, a typical collision time is 0.25. So the time is what? Look at the time itself. The time is 0.25. Okay, so let's look for we have to look for what the average force, right? Yeah, so it's very easy. Okay, 35 minus 0 will still give us 35, right? So 0.325 times 35, then divided by 0.25. Okay, so the force is 45.5 Newton. So the average force is 45.5 Newton. Okay, so you see, you find that this question is very easy. Okay, now let's go to the next question. So question 2, a football of mass 90 kg. Let's say this is a football. Okay, of mass 90 kg. Football of mass 90 kg. Okay, 90 kg running back. Okay, it's running back running back and moving to a speed of 5 meters per second. Okay. Is tackled head on by a linebacker of mass 120 kg. Run okay 120 kg running 4 meters per second. Okay. They stick together. How fast are they moving just after collision? Okay, how fast are they moving just after collision? Now this type of collision is an inelastic collision. Okay, is an inelastic collision. Now the football was moving to let me just explain. They said a football of mass 90 kg. So let's say this is football is running backward and moving with a speed of 5 meters per second, right? Yes. Okay. 5 meters per second. Okay. Is tackled head on. Let me say, okay, by a linebacker. Let's say this is linebacker. Okay, for example, let's say this is linebacker. The mass of the linebacker is 120 kg. Okay. Yes. Running 4 meters per second. Remember, if you look at it, they say head on. I don't even understand. Remember, the football is moving backward. I don't understand. Then is tackled head on by a linebacker. Therefore, let's say that the linebacker is moving towards this direction, while the football is moving backward, right, towards this direction. Okay, so they are moving in opposite direction. Okay, so the linebacker has a mass of 120 kg, and the velocity of the linebacker is what? Is 4 meters per second. They stick together. They stick together. How fast are they run? How fast are they moving just after collision? Now, if you go through our previous class video, I talked about there are three types of collision: elastic, inelastic, and perfectly inelastic. So, in perfectly inelastic, the two bodies they usually after collision, after they collide, they usually stick together and they move with a common velocity. So, this type of collision is a perfectly inelastic collision. Okay, so we have to look for what? We have to look for the final velocity. They say how fast are they moving just after collision. Okay, remember I told you guys that in a perfectly inelastic collision, after collision, both of them stick together and they move with a common velocity. So that is the velocity we are looking for. Okay, so this is very easy. Remember in okay, under conservation of momentum, the total momentum collision before collision equals total momentum afterwards after collision, right? Yes. So what is the total momentum of this system before they collide? The total momentum of this system is m1u1 plus what? m2u2. Okay. Now remember that they are moving in opposite direction. Right? This one is coming towards this side. This one is coming towards this side. So therefore, I will use what? Minus. Had it been that they are moving in the same direction, I would have used plus. But since they are moving in opposite direction, I'll use minus. Okay. Then is equals to now in perfectly inelastic collision. And like I said earlier, I told you guys that the body after collision they usually stick together, right? So the total momentum after collision is equals to V bracket open M1 plus what? M2. So the two bodies they usually stick together after collision. Okay, so the total momentum after collision is equals to V bracket open M1 plus M2 bracket close. So this is the total momentum after they collide. What is the total momentum before they collide? Okay, remember after they collide, they usually move with the common velocity. Okay, so this is the velocity we're looking for. Now, what is the mass of the ball? Is 5, right? Then times velocity is 5 as well. No, the mass of the ball is 90. The velocity of the ball is 5. Then minus m2. Mass of m2 is 120. Then the velocity of m2 is 4. Then is equals to v. We are looking for v. m1 is 90. m2 is 120. If we add this one up, we'll get let me see. We have 210. So 210 times v will give us 210 v is equals to, so 90 times 5 will give us 90 times 5 will give us 450. Okay, give us 450. Then minus 120 times 4. 120 times 4 will give us 480. Okay, so if you subtract 450 minus 480 will give us minus 30, right? So it's equals to 210 V. So what are we going to do next? We divide both sides by 210, right? If we divide both sides by 210, we have something like this. So minus 30 divided 210 minus 30 divided 210 will give us minus 0.142. So the final velocity, or their common velocity with which they move after collision is minus 0.142, approximately minus 0.143 meter per second. So after they collide, they'll move. You see this negative sign. It means that they'll remember to the guys that east is positive, west is on negative, right? So they'll move towards this side. After they collide, they'll move towards this side. So you find that it's very easy. So this is their common velocity after they collide. Okay. Now let's move to question 3. Question 3. A 2 kg block of ice. Okay, coming. A 2 kg block of ice. Let's say this is the ice. Okay, 2 kg. This is mass 2 kg. Okay, of ice is moving on a frictionless horizontal surface. This horizontal surface at time 0. Okay, the block is moving to the right with a velocity of 3 meter per second. Okay, so the block moving towards this side. The mass of the block is 2. Calculate the velocity of the block after a force of 5 Newton directed to the right has been applied for 4 seconds. Okay, now let's say this is the ball. Initially, the ball was moving with a speed of 3 meter per second towards the right? Yes. Now, then they applied, in the question, they now apply the force of, of 5 Newton, okay? They now apply a force of 5 Newton for, the time is for 4 seconds. For 4 seconds, right? Yes. So they say calculate the velocity. Normally, initially, when the block is moving, initially, when we have not applied force, the block was moving towards the right with a velocity of 3 meter per second. Now, what will happen if you now apply force? The block will now start moving at a higher velocity, right? So that is the velocity we are looking for. They say calculate the velocity of the block after a force of 5 newtons directed to the right has been applied for 4 seconds. Okay, so initially the block is moving with the velocity of 3 meter per second. The mass of the block is 2 kg. Now they now apply the force of 5 newton. The force is 5 newton, and the time in which the force is applied, the time in which the force acts is 4 seconds. So they are not telling us to calculate for the velocity of the block after we apply. Remember, the block will start moving at a higher velocity because we have applied force to it. We start moving at a higher velocity. So we are looking for the higher velocity, which is v. We don't know. Then this is the initial velocity of the block, right? So it's very easy. According to second law of second law of motion, F equals to ma. Remember, acceleration is equals to what? V minus u over what? Over t, right? Yes. So the force is what? The force is 5. The mass of the block is 2. This is the v we are looking for. Then minus the initial velocity is 3. Then the time is what? Is 4. 4 seconds, right? 4 seconds. So if we cross multiply, 5 times 4 will give us 20. Then is equals to 2 times, okay, 2 times, we now have something like this, 2 bracket of s minus 3, right? Yes. Now 2 times s will give us 2s. 2 times minus 3 will give us minus 6. Okay. So if this one come towards this side, we have it's not turn to plus, right? So now be 20 plus 6 is equals to 2s. So 20 plus 6 give us 26 is equals to what? 2s, right? Yes. If we divide both sides by 2, we have what? 2 year 1, 2 year 3. So the velocity, the final velocity is what? 13 meter per second. Okay, and the final velocity is still in what? In the right direction. Okay, right direction. Remember, the force is applied towards this side, and initially the block is still moving towards this side. So the velocity is still in this direction, okay? 13 meter per second. So now let's move to the next question, which is question 4. All right, so let's continue with the next question, which is question 5 to question 4 to question 6, okay? So let's do question 5 first do question 4 and question 6. So question 5, they said a 0.3 kg glider. Okay, let's say this is glider, 0.3 kg. This is glider. Okay, is moving to the right with a speed of 0.8. This is the right direction, right? 0.8. Then it makes a head-on collision with a 0.2 kg glider. On that glider, 0.2 kg. Okay, 0.2 glider that is moving to the left with a speed of 2.2 meter per second. 2.2 meter per second. Okay, now they said find the final velocity of each glider if the collision is elastic. Okay, so in a previous class on momentum, so you guys about the three types of collision: elastic, inelastic, and perfectly inelastic. So you guys that in elastic collision, when the body after the body collides, they separates. Yes, inelastic, when they collide, they bounce off. Okay, so if you look at this question, normally when, for example, now let's say when under elastic collision, when two bodies, both of them are moving initially. If you look at this ones now, initially, this is glider 1, right? This is glider 1, then this is glider 2. Okay, glider 2. Now initially, glider 1 is moving with a speed of 0.8, right? Yes. Initially, glider 2 is moving with a velocity of 2.2. Now, once they collide, after they collide, since the collision is elastic, they will bounce off. Yes, they will bounce off. Once they collide, they will bounce off. Let me clean this part. Okay, so now let's look at it. Once they collide, for example, then they will usually bounce off. Okay, usually bounce off and move with a particular velocity of which we don't know. So this is the velocity they are telling us to calculate for V1 and for V2. Okay, the final velocity of V1 of glider 1 and the final velocity of what? Of glider 2. Initially, they were moving with what? They were moving with the initial velocity, right? U1 is 0.8, U2 is 2.2. They were moving initially with velocity of U1, which is 0.8, U2 is 2.2, right? Yes. Now, after they collide, they will usually bounce off. They will not start moving with a new velocity, which is known as their final velocity, right? This one will start moving with its final velocity. This one will start moving with its own final velocity. Okay. So in this question, they are telling us to calculate for the velocity, which is their final velocity, the final velocity of these two glider after they collide. And the collision is an elastic collision. Okay. So that is it. So we're looking for V1 and V2. And if in that previous class, I told you guys that whenever they give you a question like this, and they tell you guys that the question and they tell you guys to look for the final velocity of V1 of the glider of the first body and the final velocity of the second body if the collision is elastic. I told you guys that you use this formula. Okay. This first formula is to calculate for the final velocity of the first body. This second formula V2 is calculate for the final velocity of what? Of the second body. So it's very easy. So let's do it. So let's look for the final velocity. So of V1 of glider 1. Final velocity of glider 1 is bracket open. The mass of M1 is what? M1 is 0.3, right? Then M2 is what? 0.2. Okay. Then divided by M1, we know that M1 is 0.3, M2 is 0.2, right? So it's plus. Now times U1, initial velocity of glider 1 is what? 0.8 times 0.8. Now plus, now since these two bodies, they are moving in opposite direction, we are going to use minus. We're going to use minus sign, okay? Yes. But if they are moving in the same direction, we use plus. Since they are moving in opposite direction, we use minus. Then bracket open, bracket open, 2 times M2. M2 is what? M2 is 0.2, right? 0.2. Then divided by M1 is 0.3. M2 is 0.2. Then bracket close times U2. Initial velocity of glider 2 is 2.2 times 2.2. Okay, so if we do everything, let's just solve everything directly with calculator. Okay, so let's just do everything. Bracket open, I'm coming. Bracket open, 0.3 minus 0.2 divided by 0.3 plus 0.2, then bracket close, multiply by 0.8, then minus bracket open, 2 times 0.2 divided by 0.3 plus 0.3 plus 0.2, then bracket close, then times 2.2. So if we do everything, we get minus 1.6. So the initial velocity, the final velocity of V1 is 1 - 1.6 meter per second. These negatives tell you that, remember they collide, right? Once they collide, this, let's say this is glider 1, this is glider 2, they bounce off, right? Yes. So these negatives shows you that the first body, the first glider, after it collides, it moves towards the left direction, right? Negative, this side, that is the west direction. Okay, this is negative, this is positive, right? So it moves towards this side, which is negative. So that's why it's negative, move towards the left. Okay, now let's look for V2. We use this formula to look for V2, which is very easy. Okay, so let's look for V2. V2 is equals to bracket open 2 times m1 is what? M1 is 0.3, right? 0.3. Then m1, we see now m1 is 0.3, m2 is 0.2, bracket close, multiplied by u1 is 0.8. Then since they are going in opposite direction, we use what? We use minus. Okay, then bracket open, m2 is 0.2, m1 is 0.3, divided by m1 is what? 0.3 plus m2 is 0.2, bracket close, then times u2 is what? 2.2 times 2.2. So let's use calculator to do everything. Okay, so bracket open, 2 times 0.3, then divided by 0.3 plus 0.2, bracket close, then times 0.8, then minus bracket open, 0.2 minus 0.3 divided by 0.3 plus 0.2, bracket close, then times 2.2. So if we do everything, we get 1.4. Okay, we have what? Positive 1.4. 1.4, that is plus 1.4, right? So I tell you that the second board is moving towards the what? Towards the right direction, which towards the east or towards the right? Yes. So this is the formula you can use. So just know the formula, okay? Just keep on make use of the formula so that you can know them, okay? Because to derive it is a long process to derive the equation. Okay, so the final velocity of V2 after they collide and move toward is what is in this direction, in the right direction, with the velocity of what? 1.4. Okay, now let's do question 4. Let's do question 4. Okay, so question 4, they said an 18 kg fish. Okay, let's say this is a fish. Okay, 18 kg. 18 kg. An 18 kg fish moving horizontally to the right. Okay, at a speed of 3.2 meter per second. Okay, then swallows a, let's say this is a fish, a small fish now. Swallows a 2 kg fish. Okay, okay, so let's say it swallows the what? A 2 kg fish. Okay, that is swimming to the left. This one is moving, this, okay, let me draw this. Okay, this small fish is moving towards, this side, right? Yes, with a velocity of moving at what? At 7.4 meter per second. Okay, the mass of the small fish 2 kg. Okay, let's say now, what is the speed of the large fish immediately after its launch? Okay, remember the initially before the, okay, so this bigger fish is moving towards the right, the smaller fish moving towards the left, and if you observe the small the this is a 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 this a collision. This type is also a collision. Okay, yes, this type of collision is known as a perfectly inelastic, because after the collision, if you look at it, they said where is it? Swallows a 2 kg fish. Swallows. So remember, in perfectly inelastic, after two bodies collide, they will now start moving with a common velocity. Okay, they will stick together. In perfectly inelastic, two bodies stick together. Okay, this is also an example of a perfectly inelastic collision, even though you have to do with features. Look at it. This one is moving towards this side, so I'm moving towards this side, and this bigger fish swallow the smaller fish. After swallowing it, they are asking us, what is the speed of this bigger one after its lunch, after it has eaten this, after it has swallowed the smaller one. So it's just like perfectly inelastic. Okay, just an example of a perfectly inelastic collision. So how are we going to do? How are we going to look for their common? Remember, I told you guys that normally, initially, under perfectly inelastic, after they collide, after they collide, they will now start. They will stick together. Okay, they will stick together and they move with the common velocity. So we are looking for this common velocity. Okay, normally these two they were moving towards each other, and this one swallow this. Let this bigger fish swallow the smaller one. They now stick together. They stay together, right? Yes. Now they're asking us to calculate for what the final velocity. Okay, so which is very easy. Remember, we are using laws of conservation moment, right? So we state that total momentum before collision equals what total momentum afterward, after collision, right? After collision. So what is the total momentum of this system before the bigger fish swallows the smaller fish or before collision? So the total momentum before collision, before the bigger fish swallow the smaller fish is that is m1u1 plus what m2u2. Okay, since both of them they are moving in opposite direction, here will not be what minus. Had it been that they are moving in the same direction, we would have used plus. Okay, then is equals to, now remember, so tell you guys that after they collide, they're perfectly inelastic. How do you know them? They usually stick together after they collide. Okay, so the two mass they usually stick together and they will move with the with the common velocity. So the two masses will do what? They usually stick together. Okay, and they will move with one common velocity. So this formula is for a perfectly inelastic collision. Okay, so M1 is what? 18, right? Then U1 is 3.2. Then minus M2 is what? 2 kg. Then U2 is what? 7.4. Right? And equals, we're looking for V, right? Then bracket up. M1 is 18, M2 is 2, right? So if we do, okay, here will be what? Here will be 20. 18 plus 2 give us 20. 20 times V give us 20 V. Then is equals to um okay, 18 times 3.2 give us 56, 7.6, 57.6, then minus 2 times 7.4. 2 times 7.4 will give us 14.8. 57 minus 0.6, then minus 14.8. So if we do it, we get 42.8. Okay, get 42.8. 42.8 is equals to 20V. Okay, so what are we going to do next? So what I'm going to do, we divide both sides by, okay, we got something like this. 42.8 is equals to 20V. So we are looking for what? V, right? Which is common velocity. Okay, what is the speed of a large fish immediately after the launch? So that is the final velocity. So we divide both sides by 20. Okay, so I'll cancel this one. So let's do it now. 42.8 divide 20. 42.8 divide 20. So that is 2.14. So the final velocity of the bigger fish, the final velocity of everything is now 2.14 meter per seconds. Okay, so that is just it towards the right. Remember, as if you don't see minus, it means that here is plus, right? Plus means that we're going to the right direction, which is positive x axis. So that is just it all about okay, that is just it for this question. Question 6. Okay, so next question. The next question is question 6. So when now this in question 6 they said a rocket in this is under rocket propulsion. Okay, one of the another application of conservation of momentum. So this is why I'm telling you guys that to go back to the to go watch our previous class video on whereby I give you guys what you need to know about rocket propulsion, the formulas and all. Okay, so this is a rocket propulsion problem. And in that class, I told you guys that the formula for under rocket propulsion there are about four formulas. Okay, one of the formula is mdv over dt is equals to ve dm over dt. Okay, which is equals to the thrust. Okay, so the thrust is either equal to this or equal to this. Another formula that I gave you guys that Acceleration, we all know that acceleration normally, you know that force is equal to ma, right? Yes. So in particular question, we ask us to calculate for, like this question, and especially calculate for initial acceleration of the rocket. So initial acceleration is equal to force over what the mass of the rocket. So this is another formula. Okay, let me question equation 2. This is another formula equation 1. The another formula is V is equals to VE. Okay, natural log bracket to put m1 divided by m final, m initial divided by m final. So this is still another equation. Okay, there's still another one again. Okay, so just go back, just go to that video, you see it there. Okay, so now let's do this question. Now, before I continue, let me just identify it. So that is why I'm just telling you guys to go through to that previous one. Now, this mass is normally the mass of the total mass of the rocket. Okay. Okay, let me try and explain it because so this mass is the total mass of the rocket plus the fuel. Total mass of rocket. Or let me not just waste time. Okay, so please just let me not just waste time. Just go to that video. You see the under rocket propulsion. You see where I explain all these parameters. Okay, so just go there. Okay, I just want to be fast. So I say a rocket in a deep outer space turns on its aging. So you can use any of this. We can use any of this formula depending on the question they're asking us to look for. Okay, so if you look at this question and they said, okay, a rocket in deep outer space turns on its engine and ejects 1% of its mass per second with an ejection velocity of 2,200 meters per second. What is the initial acceleration of the rocket? So we are looking for what? Acceleration. And remember, acceleration is equal to what? Force over the total mass of the rocket. Now the force is known as thrust. Okay, known as thrust. Now if you look at our thrust is either equals to this or equals to this. So we are going to use any of these. Let's look at force or thrust. Let's use V dm over what? V subscript E dm over dt. Okay, so this is one formula of force or thrust. Another formula of force of thrust is a force. Okay, so another formula for thrust, or you can say force, is equals to m dv over dt. Okay, so we can use any of them. All right. So in the question, they said a rocket in a deep outer space turns on its engine and ejects 1% of its mass per seconds. Of its mass per seconds. Okay, of its mass per seconds. Mass per second. So we are going to use this. Had it been that they said velocity per seconds, we use this. But if they said mass per seconds, we are going to use this. Okay, so let's look for the force. Once we get the force, divide it by the mass, we get the acceleration. So let's continue. So force is equals to, now this VE is known as ejection velocity. And the ejection velocity in this question is what? Is 2,200. Okay, then times dm. Now look at dm, there's dm over dt. Now dm over dt in the question, they said dm over dt in the question, they said okay, it turns on its engine and ejects 1%. It ejects 1% of its mass per seconds. So 1%. So everything here, the m over dt, they said that is 1%. Let me understand. 1%. They say mass per seconds. Now per seconds, which is 1 second, right? Which is 1 second. So everything here will just be okay. M divided by 1 will give us m. So we'll now get something like this. So everything here is now what? Everything here, they said 1% of its mass. Let me understand. Of its mass, okay. 1% of its mass, then per what? Per seconds. Okay. Seconds, they are referring to 1 second here. Okay, 1 seconds. So one divide anything divided by will give you that same thing, right? So the m over the t is what? Is 1% m. I don't know if you understand. So we'll put well, everything here will not be what? 1%. times what? 1% mass, right? Yes. Now 1% is still the same thing as what? 1 divided 100, right? Yes. So we'll go down. It will now be equals to 22,000. It will now be equals to 2,200 times 1% is still something as 1 divided 100. Okay, then times what? The m, right? Or the mass normally. 1 times, okay, the mass, right? Yes. So 1 times m will still give us what? Will give us m. So this 100, we cancel this on this one. We'll now be left with what? 22m, right? Yes. What are we looking for? We're looking for acceleration, okay? So we come here, we see acceleration. The force is equals to what? Our force is equals to 22m, right? So our acceleration now becomes to force is 22m, right? 22m divided by m. I don't even understand. So this m will cancel this one. So our acceleration is what? 22 meters per second square. So this is the acceleration, okay? Now let's do other questions. So so we continue with the next question, which is question 7 to question 9. Okay, so question 7 is a rocket propulsion problem. So they said, remember I gave you guys formula for rocket propulsion, and one of them is V is equals to VE, right? Natural log M initial M final. Okay, another one is trust force, which is something as trust. Or let me use trust. Trust is equals to m dv over dt, which is still equals to um, ejection velocity dm over dt. Okay. Yes. Another one, acceleration is equals to force, which is thrust, divided by what? Total mass. So we can use any of these formulas depending on the question. Okay. So just you can go back to our previous class. you will see, I explain all these things. Okay. So then they say a rocket is fired in deep space where gravity is negligible. If the rocket has an initial mass of 7,000, okay, and ejects a gas at a relative velocity of magnitude 2,000 meters per second. Now eject a gas at a relative velocity. Now this velocity is the ejection velocity. So ejection velocity is 2,000. Okay. Yes, the mass of the rocket normally is what? The total mass is 7,000. Okay. So he said how much gas must it eject in the first seconds to have an initial acceleration of 25. Okay, so let me use here. And I said, how much gas must it eject in first second to have an initial acceleration of 25? Okay, so let me see. We are looking look at it. Let's see. We are looking for they said how much gas must it eject in the first second to have an initial acceleration of 25. Okay, so which formula are we going to use? We cannot use this first one. Okay, we are not going to use this first one. Okay, so we neglect this first one. So this first one is hard. Okay, then the second one, trust is either we are looking for what they are looking for. They said how much gas must it eject in the first seconds. So we are going to use this one. Okay, they gave us VE, which is 2,000. Okay, they gave us VE, then they gave us VE. Okay, then they gave us the total mass of the rocket. I know normally. Then they said we should calculate for the how much gas must it eject in the first seconds. So I'm going to use this formula for force. Okay, that is the mass, the how much is talking about the mass. I don't even understand of the gas. How much gas must it eject in the first seconds? So this is the ejection velocity normally. Then this is the ejection velocity. Now they're asking us to look for. They said how much gas must it eject in what? In the first seconds. So looking for dm, and the time is 1 second. So remember they say the first seconds, that is 1 seconds. Okay, how much gas must it eject in the first seconds? So we are going to use this. We are looking for dm. I don't even understand. We're looking for dm. Okay, and this formula is equals to thrust. So thrust is equals to what? Is either equals to this, but we're not using this. We're using this. It's equals to ve dm over what dt. Okay, yes. And we don't know force or thrust. We don't know force. So we will need to first look for force first before we get the M. How are we going to look for force? Force is equals to what? Ma, right? We make calculation and yes, force is equals to Ma. Now the M M is the total mass of the rocket, and they gave us total mass of the rocket is 7,000, right? Yes, there's acceleration. They gave us acceleration to be 25, right? That's have an initial acceleration of 25. So if we multiply everything, we get the total force. We get the force or the thrust. Okay, so 7,000 times 25. 7,000 times 25 is 175,000. Okay, so 175,000. Okay, so we have gotten our force or thrust. Okay, so we usually, okay, let me clean this part. We usually impute it here, which is 175,000 is equals to what? Is equals to, now remember, I told you guys thrust or force is equals to m dv over dt. It's still equals to ve dm over what dt. The reason why we are not using this is because the question says so. They didn't give us the v, they didn't give us the v, they didn't give us the t. So in the question they are even asking us to look for what? The how much gas does the rocket expel or eject in the first seconds? So we are using this formula, F equals to this formula, F equals to this. So we need to look, we look for F first. Once we have gotten our F to be 175,000, right? Now our ejection velocity is what? 2,000. Okay. Then we're looking for the helm. Now remember the T is the same in the first seconds, right? So 1 seconds. Okay. This zero will cancel this zero. We left 175 equals to 2 dm divided by 1. Anything divided by 1 will give you that same thing, okay? So we are looking for dm. Let's divide both sides by 2. This one will cancel, this one will cancel. 175 divided by 2 will give us what? 175 divided by 2, I'm coming, give us 87.5. Okay, so the the mass of the how much gas does this expel in first seconds is 87.5 kg of gas that the rocket expel in the first seconds. Okay, so that is 7.5 kg the rocket expel in first seconds. Now let's do the second question. They said a truck moving with a velocity of 10, that is u1 initially. U1 is 10 meters per second. Okay, of 10 to the right. Okay, hit a bicycle also also moving to the right with a velocity of 6. So the velocity of the bicycle is 6. That is the initial velocity. Now after the collision, the truck and the bicycle move to the right with a velocity of 6. Okay, this one, the v1, this is not the final velocity of the truck after it collide with the bicycle, and 5.5 respectively. So V2 5.5. This is the final velocity of the bicycle after they collide. Okay, what are they asking us for? They say what is the coefficient of restitution of the collision? So coefficient of restitution, I also explained that one in our previous class. So I'm looking for coefficient of restitution, which is very easy. Okay, coefficient of restitution is equals to what? Is equals to change in final velocity. Change in final velocity over change in initial velocity. Okay, so the final velocity is what? V1 minus V2, right? Then this is the formula for coefficient of restitution. V1 minus V2, then divided by U1 minus U2. Final velocity divided by initial velocity. So final velocity of V1 is what? 6. Final velocity of final velocity of the truck is 6. V2 is what? 5.5. Then U1 is 10. Then U2, U1 is 10, then U2 is 6. So if you do this, if we do this one, I'm coming. So let's do 6 minus 5.6 minus 5.5 give us 0.5. Okay, give us 0.5. Then 10 minus 6 give us 4. So if you divide it, everything get 0.5 divided 4 is 0.125. 0.125. So the answer is 0.125. So it's very easy. So this is formula for calculating coefficient of restitution. Okay, this is the formula. Now let's go to the next question, which is question 9.